Good evening, everyone. A warm welcome to Techloop Alpha, where we'll be introducing you to various domains. You name a domain, and we have got you covered, ranging from web and app development, machine learning, cybersecurity, and blockchain and tech to domains like augmented reality, virtual reality, UI UX, graphic design, and many more. Now, let's get started with the first domain, that is web development. I'd like to call Amog and Varun to take over now.
Um,
Just a confirmation, are videos and mics working?
yo, I can't. What happened?
We are just waiting for Amok to join the call.
Hello everyone. Just a mic check. Everything's looking fine. Can I get a confirmation? Okay. So we are IEEE VIT, one of the student technical chapters of VIT Valor. We are proud to welcome you to Techloop Alpha. So you would be wondering what is Techloop? Techloop is an initiative that IEEE VIT started in 2013 that was students teaching students. And IEEE stands for the motive that students should gain all the knowledge and then spread the knowledge with them. So we've taken tech loops in around 15 domains over these 9 years. So what do? We do design, we do machine learning, we do augmented reality, we do app development, web development, cybersecurity, electronics, blockchain, game development, tech, competitive coding, you name it, we have all the domains. So IEEE-VIT promotes its members to go to different events. So I'll show you what we've done in the past few years. So these are some international hackathons that we've been a part of. So the picture over here is of Hack MIT. Then we've been to Hack Harvard. We've been to Start Hack 2019. We've been to JP Morgan Code for Good, and we've won multiple prizes in these hackathons. So some national hackathons. These are pictures of Smart India Hackathon and multiple national level hackathons that are hosted by the government of India and multiple colleges over the country. So IEEE also holds the record of most wins in internal VIT hackathons. So members of IEEE VIT have been parts of programs like Linux Foundation Mentorship, Google Summer of Code. Then certified ethical hackers are a part of IEEE VIT. We've been a part of Summer of Bitcoin. We've been a part of GitHub externship. Then, so some of the events that we did this year were Enigma. So Enigma was a 3-day online cryptic hunt that hosted around 2,400 plus participants and was spread around in 75 countries of the world. So then we hosted the CTF. So CTF is a cybersecurity based event that had around 1,200 participants and was spread over 10 plus countries. Then we had Palette. Palette is a one of a kind design hackathon, which we host every year, and it has speakers from IBM, Walmart, and Microsoft. And this is also spread over 65 plus countries. Then, since IEEE loves open source, we hosted our own fest during Hacktoberfest that was affiliated to the Hacktoberfest organization called FOSS Fiesta, in which we informed people the importance of open source and how they can get into it. Then, in the last few years, we've made the first season of the Techloop podcast. So, Techloop podcast was an initiative by IEEE VIT that showcases different individuals who are doing well in tech on a podcast. Now, we'd like to welcome you. This was our time at IEEE VIT. Now, I'd like to hand over the stage to Anish again. We'll be also hosting a recruitment soon, so stay tuned. Anish, you can take over.
Hello. Yeah, thank you, Arush, for that lovely presentation about IEEE. And it's really well said. Whatever you said about that, we actually do them. Now, Varun and Amog will be taking over for the web dev session. Hi, Varun. Hello, Amog.
Hello, Anish. Just a mic and screen check.
Yep. Yep. I can hear you, Varun. Amog, if you can. What do you think about what would we do in today's web dev session?
I mean, there's a lot of things to cover, and considering we have 11 domains to cover today. We'll be able to give a glimpse of every domain. And as we have recruitments coming up, you know how important it is to know before you get into anything. So today we'll be helping everybody understand that.
Amog is also here. Hi, Amog.
Hi guys, how's
Yep,
everyone doing today?
everyone. You can put it up in chat box, guys. Anything that you'd like to say, it's open that you can comment.
That's great.
Alright, guys, I'll leave.
All right.
So, good evening, folks. Thank you all for attending this session here on YouTube today. This is your web host number one, Amogaria, and
This is Varun Murpani, your web host number 2. Or if you're from my city, you can call me your local host too.
so all of y'all are gathered here because you want to get started in tech. Well, you're at the right place. So, Varun, any idea as to how we can hook these young, beautiful minds into loving web development as we do?
I see the pun there, Amog, but not sure if our audience got it. And we're here just to explain that.
For sure, dude. If web development has taught me one thing, that is to know all the crazy good buzzwords so that I can always stay in the loop.
So the first question which comes to our mind is, what is web development? Simply put, it is the art of building, maintaining, and beautifying websites. So web is not only, making websites at this point, web is backing all the applications you can interact with. So moving on, we will extend this structure to you. The website is divided in two major halves, which is the design aspect and the development aspect. Designer takes care of the aesthetics, UI, UX too, and they beautify the website. So we have a UI, UX session coming up shortly, whereas the developers can be further classified as front end and back end.
Guys, now pay attention because things are going to get serious. So, what we see here is this gentleman trying to. What we see here is this gentleman excited to be on a plane and trying to share his wonderful experience via an image. But hey, this is just the front end. That is what we see and perceive his experience to be. Whereas this gentleman is actually doing a lot of work behind the scenes to make his final picture, which we refer to as the front end, look great and enjoyable. So, guys, this is it. Front end is something which you see and perceive, whereas the back end is something which you don't. There are pretty smart people out there who do both front end and back end, okay? And they are called full stack developers. But from this picture of Patrick, we see that the stress gets the better half of them. Although this does not mean that being a full stack dev is a bad idea. What we wanted to say was take one stream, either front end or back end, and stick with it until you master it completely. For example, I personally started with back end, and my friend Varun here started with front end. And now we can manage both the aspects pretty well. So, to be precise, the content which you see on your browser is the front end. When you submit or click on something on the front end in your website, it sends a request to your web server. What is a web server, you ask? Well, it's like the brain of your website. It decides what should happen when a certain request comes from your front end. Too many terms? Okay, let me put it this way. Imagine your parents are the back end and you are the front end. Now, one fine day, you go and ask your parents for $1,000, and then they can make a calculation. They calculate whether to accept the response and give you $1,000 or to reject the response and give you a good old scolding. But either way, when you request something to your parents make a calculation. Now, after they have given the response, which can be either positive or negative, they will obviously remember it in their memory. Now, this memory in developmental terms is called database, basically where you store your data.
So let's dive deep into front end first. So what you see here is HTML, which is the markup language, contains the skeletal or the body, but CSS, it helps us beautify it. Here's another example which will make things even more clear. So the HTML gives the structure of the car, whereas CSS helps us make it look flashy and, cool. And then there's another language which is called the JavaScript, which adds functionality. So what happens is when you hit the brakes, the car should stop, or when you accelerate, the car should move forward. And that's the same as when you click a button on a website, it should do something, and that is handled by JavaScript. So here's a live demo to explain things further. So this is a website we have built at IEEE-VIT from scratch to help with the core committee selections which are coming up. And as you can see, all the content on this website is through HTML, which is the skeleton or the body, whereas CSS helps us, beautify it, as you can clearly see. And I want you to guess what will happen when I click on this button. So this button it'll help through JavaScript. And when I click on this button, it sends a request to the backend where I'm verified, and it takes me to the form. I'm logged in and taken into the form. For demonstration purposes, I'll fill the form, but I hope you do not do the same because you can submit the form only once.
Only once, guys. Remember that. What you see on the screen here is done strictly by professionals. Please don't try to recreate it at home.
All right, so when I click on the submit button, what will happen is my request is sent to the backend or the web server, and then all my data gets stored in the database. As you can see, the request is being processed, and if you want to make such cool websites, and you know where to come. Amog, over to you.
Yes. So, guys, you must be thinking, oh my God, this is very tough, where I don't even know how to get started. I'm very new to development. Well, don't worry. We at IEEE have got you covered. We have curated a wonderful list of a site of resources filled with resources which can get you started in web dev, which covers basics from for stuff like Git and your first IDE to a wonderful roadmap which we have created over the experience of our years. So we have our very wonderful roadmap. We have advanced roadmaps for when you become a pro. We have CSS, JavaScript, introduction to full stack, Flask, Django, and many more. So these are some of the few languages which can be used. So thank you for that demo, Varun. These are a few languages which you can use to write your backend. Okay, you can use any language to write your backend, but it is not majorly the language which lets you write efficient and wonderful code, but it is the features of the libraries which make all the difference. The most popular ones listed here are Python, Java, and JavaScript. Yes, Java and JavaScript are completely different languages. Don't mistake them to be the same thing. So I'd like to conclude by saying that not only is web development madly interesting, it has a very bright future with tremendous amount of job opportunities. As we see the slow but steady transition to the metaverse, more and more web applications would be needed. Every up and coming person or even a business has a web presence, and in this day and age, it has become more of a necessity than a luxury. So, Varun, do you want to conclude and tell what we have learned till now?
Yeah, definitely, Amog. We saw and understood the differences between front end and back end. We had a brief summary about how web development actually works. We saw the live demo and figured a few of plethora of tech stacks which are involved in web development. And not to forget, we saw quite a few buzzwords as well.
That's true. This indeed was a great experience for us both. This is Amog Arya signing off. Please feel free to post any of your doubts in the comment section, and we will get back to you as soon as possible. And if you feel that your doubts have not been answered here, make sure to join our Discord community, which is also the Techloop community, to have all your doubts cleared at the same place. So now I'm transferring the stage back to Anish. Thank you and have a wonderful day.
Thank you, Varun. Thank you, Amog. That was a really interesting session that you guys took, explaining the basics of web dev. Now we have Mayank and Jatin who would be explaining us about app dev. Hi Mayank, hi Jatin.
Hello,
Hi
Anish.
Anish. Hi Jitin.
Over to you guys.
Yeah. So, hello everyone. I am Jatin, and I will be taking the Techloop Alpha session on app development today. So, in this session, we will be covering both your domains, both the platforms, Android and iOS. And along with this session, you will get to know how can you start a journey as an app developer and what are the tools and tech stacks you require to start making apps. So, let's get started with the session. So the first question is, why should you learn app development? Like, is it really beneficial for you to invest your time and learn app development? So let me tell you some facts that will answer your question. Like, why should app development only? So around 2.5 billion people all over the world uses apps every single day. So it means it covers 90% of the people all over the world. And if we talk about the global market share, it consists of 99% of the global market share by the end of 2022. So as you can see, this app industry is very big and it is growing day by day. Now let's talk about the business side. So some of the famous tech giants like Flipkart, Amazon, Instagram, Uber, and PUBG, their revenues are depend mostly on their mobile apps. So if we talk about a number, so around $111 billion are the total revenue, which includes both App Store and Play Store. Now let's move to our first platform, which is Android. So you surely heard this term before, Android. And the first question that comes to your mind is, what is Android? So let me tell you, Android is a basic mobile operating system by Google, which is based on Linux kernel. And it is used by most of the people all over the world as products, smartphones, and smartwatches and TVs. And if we talk about a fact about Android, like it was really built for digital cameras, but then an American company called Android thought to develop it for and smartphones also. Yeah, and there's an amazing no, I would say pretty sweet fact about Android. Like it is very innovative with the names of desert. The reason behind that is since this devices makes our life so sweet, so every Android version is named after a desert. Yeah, that's all about Android. Now let's talk about what do you need, like what all tools do you need to start making your Android apps. So first of all, you will be needing an IDE called Integrated Development Environment Android Studio by Google, which was developed by JetBrains and originally built with an IDE called IntelliJ, specifically for Android development. Along with that, you will be needing an emulator, which you can directly install from Android Studio, or you can test your apps in your mobile apps via USB debugging. And if I tell you about Android Studio, so Android Studio is a very easy software. And, everyone can use Android Studio and can make apps very easily. And there's a fact about Android Studio, like it is a very heavy software, so it requires a lot of resource of a device. As you can see in this slide, now you have the required tools, but along with that, you will be needing some knowledge of programming languages also. So you can make apps either in Java or in Kotlin. So these are the brain of your apps, like it controls the whole functionality of your app. So Java is mainly used in early ages, but nowadays Kotlin is popularly used because it was announced as the official language of Android development and because of many functionalities. Like if I say in simple words, you have to write lesser code in Kotlin than Java for the same exact function. So that was about the functionality part. Now let's move to the interface part, the user interface part. So for that, you will be needing XML, which stands for Extensible Markup Language, which have a set of rules like that converts a document in such a manner that it will be readable for both a machine and for human beings also. And the most important part before starting Android development is you should have a decent knowledge about OOPS, which stands for Object Oriented Programming. And like because most of the concepts in Android development is basically based on OOPS. And I'm pretty sure that you guys already learned OOPS in your first or second semester. And now let's move to the second platform, which is iOS app development. iOS is a mobile operating system which was created and developed by Apple Inc. And apps for iOS are written in Swift. And along with that, there is a requirement of MacBook and iMac to create MacBook or iMac to create iOS apps. And and along with that, you will be needing a tool or I should say IDE, similarly like Android Studio, called Xcode, and you should have a decent knowledge about a programming language called Swift. There is a benefit of iOS development is like you can make apps for both Mac OS and iOS using a single IDE called Xcode, and similarly you can make apps for both app Mac OS and iOS using a single programming language Swift. Now we will be moving to the next part, and Mayank will tell you about cross-platform app development. Yeah, Mayank, over to you.
So, hello everyone, I am Mayank, and since we have already discussed a bit about what is Android, what is iOS, and how are they are developed in natively, but I have some good news for you. So, let's skip to the good part, and
Yeah,
there's another way to make apps for both iOS and Android, but write the code just once. Maybe that's what you're looking for, or the most of people will. Because that's what we want. Why would anyone don't want to make an app by for multiple platforms, but just by writing the code once? So let's head on to the next slide. And here we are. So these are made using cross-platform frameworks. So the first question you might have is, what are cross-platform frameworks? Cross-platform frameworks are the tools which help us make apps or applications for different platforms just by using and writing a single code base. So, but why do we need them? Assume you have a local local business and which does not you do not have a much investment to do so. So what you can do is just rather than hiring different developers for multiple platforms, you can just hire one and tell him to make apps for both the platform, which is Android and iOS, with just a limited resources and investment. So for an example, let's talk about Flutter. uh, so, what is Flutter? Flutter is an open source framework made by Google to build mobile applications and as well as for desktop applications, which covers Mac OS, Windows, iOS, and Android. Yeah, in Flutter, to make the UI, every different element of Flutter application is a widget. That's an interesting fact because from the app bar to the text view, a button, everything, all the parts of Flutter app is a widget, which makes it interesting and helps us to build beautiful UI easily. So, but there are more ways to create cross-platform apps, and Flutter was just an example. So, covering on to the next is Xamarin, which uses .NET Microsoft framework, uses C# language to develop cross-platform applications. Next is Unity. Although Unity is a popular game engine, but you can use it to create non-game apps using C#. And the last one being React Native, which uses JavaScript to make mobile applications. Yes, it is fascinating because usually we use JavaScript to make web applications. But here Facebook, which is now Meta, came up with the fact and they made React Native to make mobile applications for multiple platforms just using JavaScript. So covering up all these things, we now talk about pros and cons of cross-platform applications. So the pros of cross-platform are it is faster to develop apps in this, it has multi-device support, and you can just have to write the code once, as we already discussed. But the disadvantage or the cons of cross-platform are it lacks libraries because libraries are first created for native applications, then they are ported for the cross-platform. And due to this porting and all this compiling thing from the cross-platform to native, the file of app usually increases, and thus leading to lower performance than a native app. So this covers the basics of all the app development from Android, iOS, and cross-platform. Now let's see what we do at IEEE VIT in app dev. The first one is Enigma 8, which was listed in the top 10 apps in App Store and as well as Google Store, which we conduct annually. The second one is our LEDBus app, which is an app to manage a IoT-based project, which helps us to display the timetable on a ceiling fan. Amazing, right? So making our life easier. Mm, and you can so next here on we if you have if you want to get started in what am I
Yeah, you're audible, Mank.
sorry for the glitch. So now you must be having the question. We all know what these domains are, what the different development tools are, but how to get started. So to getting started in app development, you head on to Android developers website. You can use Google Colabs, or you can use online tools such as YouTube or some online courseware such as Udemy and Udacity for structured courses, and as you prefer. But while developing, you might get across some errors or bugs which you want to fix. So what you can do is just go copy paste the error and go on to Stack Overflow. So and search the most probably you will find the answers there. But if you can't, you can always head on to our Techloop Discord community server and and get your doubts clear with experienced developers. So now me and Jatin will sign off and we will head on to the next domain. Over to you, Anis.
Thank you, Mayank. Thank you, Jatin.
Thank you, Anish.
Next up, we have KP and Akshaya who will be taking up ML. Hi, KP. Hi, Akshaya.
Hi Anish.
Hey
How you
Anish.
guys doing?
Hi Akshaya. I'm fine. How are you?
Doing good as well. I hope the screen is visible, guys. Over to
Yes.
you.
Yep.
Great.
Hey everyone, I'm Akshaya.
And I'm Kavipriya.
Today we're gonna take a look at the most popular domains out there, machine learning. Before we start, take a look at the question given in the screen and keep thinking. So before we start, a lot of you might have come across the term machine learning and might have felt scary about it. Now, after the next 10 minutes, you'll not only be able to have a conversation about ML with someone, but also interested enough to explore more about it. So, KP, what is ML?
When you Google what is ML, you find that machine learning is the study of computer algorithms that can improve automatically through experience and by the use of data. It sits at the intersection of statistics, linear algebra, and computer science. Did that just go over your head with buzzwords like AI and algorithms? Let's make it simpler. Machine learning is about teaching computers how to learn from data and to make decisions like humans. Instead of writing code explicitly, we feed data to these ML algorithms and they build their own logic based on the data and its patterns. Now let's look at another interesting term. You might have definitely heard about artificial intelligence. One of the most searched Google requests is, are artificial intelligence and machine learning the same thing? Raise your hands if you think it is the same. Actually, put your hands down because we can't see it. So, if you thought AI and ML are the same thing, let's clear the confusion now. We have AI, ML, and DL, and these are three different things. Artificial intelligence is everything related to making machines smarter, and machine learning is a subset of AI, and but this is a bit more specific and particular. And deep learning is a subset of ML, and this is where the real magic happens. To elaborate, artificial intelligence is any technology that mimics human behavior and appears to do something intelligent. Since the dawn of technological development, humans have been very fascinated with the automation, and this technology AI allows robots to think without the need of human involvement.
Oh, yes, this is one of my favorite memes of all time. In films like Matrix, Terminator, and Interstellar, artificial intelligence has been a key theme. Although Hollywood blockbusters and science fiction novels depict AI as humanoid robots taking over the world, AI's progress is not that smart or even dangerous in that matter.
Alright, so we looked at AI and ML. But what is deep learning? No, not this. This. Deep learning is a special type of machine learning which has unique ability to find patterns in anything on its own.
Before we go to the next part, how many of you here has hesitated to start ML because you heard it was math intensive? Let us know if you have thought the same way. And for your information, no, you don't have to be really good at ML, really good at mathematics to get started with ML.
Alright, so we know what all these terms mean now, but where do we use it and where do we see it? There are a variety of everyday applications for machine learning, And machine learning and AI are used everywhere, from Google Autocomplete to Siri and Alexa. Now we have something interesting called Google Quick Draw. It is a machine learning based game. A neural network tries to guess what you're drawing as you draw it. But of course, it isn't always successful. However, the more you use it, the more it will understand and learn from it. So this is just one example of where machine learning is fun. You can check it out later.
Okay, now that you have seen what AI and ML is, let's take a deep look at what ML really is. ML is generally further divided into three: supervised, unsupervised, and reinforced. Let us start with supervised. Let us say I'm giving a machine 100 images of cats and dogs and give the answer as well, whether it is a cat or a dog, and feed it into the computer. I expect the machine to, for the next time I come up with an image, let's say I give it a dog's image, it should tell me that it is a dog. Now, this is an example of supervised learning. Now, remove the part where I gave the output as whether it is a cat or dog. Remember? Now, take this out and this becomes unsupervised learning. That is, you're basically leaving the machine in an uncharted territory to figure it out by itself, whether it's a cat or a dog. Now, the third type is reinforced learning. Now, reinforced learning is basically it works on feedbacks and rewards. Let us take rewards as something like a positive feedback and punishment as a negative feedback. Does the word rewards and punishment ring a bell? Of course, they are human behaviors. We humans tend to go in a direction where we see a reward, and that this is the same as that. Now, coming on to this, we all might have experienced at the start of opening an account on YouTube or any other streaming platform, all the recommendations would have been random. But the more we use it, the more personalized your need, it accustoms to your personalized needs. Now, what happens behind the screen is the computer employs trial and error to come up with a favorite video that you might click on next time. To summarize, there are three types of machine learning. One is supervised, unsupervised, and reinforced. Supervised is giving an input and output. Now take out the output and let the machine to figure it out by itself. It becomes unsupervised. And reinforcement is basically you neither give an input nor an output, and it works completely on feedbacks.
All right, so we learned about the basics and the information about machine learning, but what do we do and how do we do it? So let's look at what we use to do ML. There are several machine learning softwares out there, so let's take a brief look at them. We have languages like Python and R, which are most widely used in machine learning, but Python is the most popular one. And we have libraries like NumPy and Pandas, which are used to cleaning and working with datasets. In case you want to visualize your datasets and outputs, you can use Matplotlib and Seaborn. So you must have heard about NLP, the term, which is called natural language processing. So in case you want to use natural language processing, NLTK is a library that you have to go for. And we have TensorFlow, Keras, and PyTorch, which are famous libraries for deep learning. And now we have softwares and IDEs that are used for training your machine learning model. In here, Jupyter and Google Colab are the most commonly used. The interesting thing about Google Colab is it is a hosted Jupyter notebook that requires no initial setup in case you prefer not to use your own machine, local machine.
Now, here at IEEE, we love exploring ML and coming up with different projects. Now, the first project you see there is an ongoing project where you give in a tweet and the machine should basically predict what is the amount of reach it will get and which is the best time to post it. And it works something like you can get a lot of inputs like whether it is a tech or a politics tweet. Now, the second thing is Autograder. This is an awesome performance. Now, Autograder is an Hacktoberfest project that we did, which is basically the teacher automates the process of assigning a project and evaluating it. And the third is Game AI, which is basically building an AI that could play a game, let's say chess, for example. And then the fourth project is WhatsApp Chat Analyzer. You could import a chat of your WhatsApp chat, and then it will come up with various analytics like who will reply to you next, or who's the most replied one.
Well, these all sound like really cool projects. So we are almost at the end of our machine learning session, but do not worry if you're feeling overwhelmed right now. That is why we at IEEE-VIT have put together a step-by-step guide for beginners that will show you how to use and apply all of these tools.
Now, this is the IEEE curated resource library. And since you can see here, we start with a roadmap that you can check out. And we also suggest that you start with Python, since you might have already, there's a high chance you might have already learned this in your school or your first year of college. And then you could basically develop your various skills, like there are a lot of Python libraries like NumPy and Pandas, which you can use for data analytics. And then we have a lot of courses given out, which will fit perfectly if you're just starting out.
So, we live in a data driven world and there's tremendous scope for a career in machine learning, but it's a long road. And if you have any doubts, ping us up in our Techloop community and discuss with us. Happy machine learning. Thank you, and over to Anish.
That was a wonderful session, KP and Akshaya. I loved every bit of what you said. Now, next up, we have Mayank, who would be we'll have Himanshu, who would be telling us about electronics.
Hello, Anish.
Hi,
A quick
Himanshu.
check if I'm audible and screen is visible.
Yes, you're audible and visible, Himanshu. Your screen is also visible.
Yeah.
Stage is yours now.
So, good evening, everyone. Myself, Himanshu Shah, and I'll be taking today's session, Introduction to Electronics. Let's talk about one of the major core engineering fields. You see, the fundamental question comes here is why to choose electronics? Instead, I would say why not? Just have a look around your room. You'll find at least 5 electronics devices from Alexa, even to some people have robotic vacuum cleaners. So even electric vehicles nowadays are in light. So every industry is trying to get it automated. So let's see some stat also. Here are some of the global companies and their investment made in robotics, AI, ML, electronics for R&D. And in general, the average salary of a robotics engineer lies around 60 to 80K dollars per annum. So definitely we have a very good market and good opportunity for electronics engineers. The electronics can be majorly divided into three domains: embedded systems, Internet of Things, and robotics. We'll talk about each of them. Okay, so what comes to your mind after seeing this image? Like, let me just have a look at the chat. Yeah. So for me, I can see something similar to a motherboard of a computer. So this is what something an embedded system looks like. So yeah, an embedded system is a set of hardware and software designed to carry out predefined tasks. So microcontrollers, there is in the left image, and microprocessor on the right are parts of an embedded system. Like as you can see, these chips have multiple pins. So these are all the different pins, and we can connect them to different sensors and use them for via writing code. So these are the various fields where embedded systems are used, from gaming, consumer electronics, industrial equipments, cars, everywhere we use embedded projects. So Arduino and Raspberry Pi are one of the best generic development boards to get started with. So what are development boards? Development boards are just PCB designed in such a way that they are user friendly. That means beginners can use them directly without doing any kind of soldering. Also, you can make projects from basic level and even projects of higher complexity. So Arduino is the best way to start your journey with embedded systems. And also the biggest advantage of Arduino is that it reduces the complexity of the circuit by its beginner friendly design. So as you can see, instead of having this much wires, I'll just use an Arduino. That's all. Like all I need is just that thing. So, well, Arduino has many advantages for a beginner. The vast documentation of Arduino help you getting most of your doubts clear. And believe me, whatever type of project you think of, there's a well and good chance that the similar thing would have been made by someone in the world, and it will the documentation for that will be available, and even with a video. So, and it is very easy to code. So we use Arduino IDE to code it. It's very easy. Then these are some of the projects. On the left side, we are having a self-balancing robot. So like even if you give a torque, so it balances it accordingly. So it has multiple sensors, gyroscopes and motors to balance it properly. And on the right side, we are having a bi-rotor drone. So well, this drone is not a particular embedded project. It is combination of robotics as well as embedded, but it's obviously a cool project, as you can see in the images as well. So here are some good projects for Arduino as well. So on the left side, we are having a spider robot. So it is controlled over an app. And on the right side, we are having a gesture controlled car. So as per your hand gestures, the car is controlled. So these are some of the good projects that you can make using Arduino. So next thing is Raspberry Pi. The development board Raspberry Pi is much more advanced compared to Arduino. It is 40 times faster than Arduino. You can even connect multiple sensors to it. So this board is what looks like an Raspberry Pi. So you can connect multiple sensors to it. It can be used as a fully furnished computer as well. You can even play Minecraft on it. Believe me, it's very powerful chip. So here are some projects made using Raspberry Pi. So on left side, as you can see, this is a camera system made using Raspberry Pi. So you can have it set up on outside your door and it can detect people. And on the right side, we are having a Christmas tree lighting made using Raspberry Pi. So you're controlling multiple lights using Raspberry Pi. So let's talk about IoT. So what you all can see in this image, like any responses I can get from the chat. Okay, so I'll see. This is not the IoT we are talking about, where fridge and toaster are having a chit chat, obviously. But like as we talk about projects earlier, here IoT gives an addition of connectivity to internet. IoT, as it says in the name, we connect things through internet embedded with sensors, software, and other technologies for the purpose of exchanging data with other devices and systems. And even we can control things over internet. So using IoT, you can even control any device in any part of the world from any part of the world via internet. It can be used for processing any type of data as well by uploading it to cloud. So now the as a simplest project you can start with is home automation. This is on the left side, as you can see. This project is just a very simple project. You're using 4 relays and one node MCU, a development board, about which we will talk later. So this project can be used to switch on and lights and on and off about the lights. And on the right side, you're having a bit advanced project. It is the world's smallest switch button connected over internet. So on the right side, as you can see, this small button, and like we can use it to control any of the lights or switches that we want over internet. So getting started with, so this is what the node MCU is I was talking about. It is also another development board which has a Wi-Fi chip on it, so you can connect it with internet and use. There's an add-on for this node MCU on the Arduino IDE that allows you to program this on Arduino IDE itself. So it's very user friendly. It has a very good documentation as well. So can be very useful for starting your IoT journey. So let's start with robotics. We all love Atom, don't we? So why robots? Well, I would say because we engineers are lazy, but there are more solid reasons than that as well. Let it be working for hours or say getting highly precise results in any task, they can do everything for you. So this is an actual robot that you all can see. Atlas, one of the robots made by Boston Dynamics. As you can see, it can perform multiple complex actions. Yeah. And the next thing we have is Spot. This is also another quadruped robot made by Boston Dynamics. So as you can see in the video, it's full of sensors, and it is one of the leading robots in the industry. This is also one of the famous robots that we have. So now, after watching all this video, you must be thinking this, right? You need lots of bucks to make a robot. The quadruped robot Spot that we just saw is sold at 75K dollars. So just imagine the overall project budget. So, but you don't actually need money to learn robotics. So what we have is ROS, Robot Operating System. ROS got you covered in case of learning robotics. ROS is a more of a middleware, something like a low-level framework. So using ROS makes it easier for a software developer or robotics enthusiast to design programs to operate robots without actually buying hardware, just by making simulations which are very much accurate to the real world. And let me tell you, this simulation is also made in ROS only. This is how a Ros interface looks. You can run multiple scripts in here and it works on Ubuntu OS. So the advantages of ROS being it has packages ready for everything. It is language agnostic, which means you can communicate between a Python and C++ nodes. ROS has many great simulation tools such as RViz and Gazebo. With this, you can even add physical constraints to the environment, and you don't really need to invest your whole time to create everything from scratch. You can just work on a particular part of a robot as well. So you get many of the packages ready made. So this is how a ROS simulation looks like. This one is of a Prius car. Yeah. So this is the Prius car simulation. Yeah. So here comes the sensors parts. So like as you can see in this image, the robot perceives different objects in the environment. This is where embedded comes in picture. So getting data from different sensors and giving it to the computer, and as per that, computer processes it. So that the car can perceive what other objects or things are there in the scene. And here also you can see different camera angles as well at the same time. So next we have is what we make at IEEE. So here's one two-wheel drive car controlled over internet using ROS. So you just need to control it using your laptop keys. So like you just use your up down arrows and the car will run. Then next we have is LED bus. So another project made by us is a perception of vision display device. It's called as POV display device. This thing is actually set up on a ceiling fan. Yes, on a ceiling fan. And the project was to get the class timings displayed on your ceiling fan. So you have an app, you can add just timing, and it will display it on your ceiling fan. So this is what the setup of LED bus was. So here you have an array of LEDs set up here, and it is set here on a fan. So accordingly, it changes the on and off condition of LED, and as per that, it shows the output. This is another project that we had, was an autonomous car. So it was it just avoids the obstacles and goes ahead flawlessly. Thank you so much. If you have any doubts, please put it up in the chat box. And we will also be providing a well-documented resource page for you to get started with electronics. And now over to you, Anish.
Thank you, Manchu. That was a really interesting session about electronics that we saw right now, and I love the different robots that you showed and different kind of devices that you are tried to see. I mean, that was really amazing. Next up, I'd be taking a session on cybersecurity. I hope my screen is visible. If you can, let me know that in the chat box, please. Cool, then I guess I'd start now. Yep. So this is welcome to the session on cybersecurity, and I'm Manish Panda, a second year student at Velo Institute of Technology. So let's get started with what exactly is the need for cybersecurity. You all might have heard stories that your friend's Instagram account got blocked or got hacked. And at times, you might have seen that your grandparents come and complain to your parents saying that they lost money from their bank account. Um, do you guys have any idea why does this happen? I mean, there are many reasons that can happen like that because of this, which can happen, and all of this takes place, and we need to make sure that we do not repeat it in the future or do not make these mistakes. Recently, we had seen that Domino's had suffered a huge customer data leak in India, and the customer details, their addresses, their phone numbers, their bank account, the credit card numbers, all of them were available on the web. And because of these, companies are nowadays taking steps and making sure that they do not face issues with respect to these stuff, and their customers also do not get their data leaked. Coming up to next, what is not cybersecurity? So one thing about cybersecurity is I've seen people tell that cybersecurity is something that we have seen in the movies or in web shows or series, saying that people go around typing something on keyboard. There's long lines of code printed on the terminal or the screen, and then they're going around doing dance and stuff, as you can see in the GIF book here. But that is not exactly what is cybersecurity. Then, what is cybersecurity? In simple terms, it is securing something from unauthorized access and making sure it reaches the right people only. Suppose you have a bank account. Now, if you'd want to access that bank account, it belongs to you. You should be the only person who is able to access that bank account, no one else. And that, in short, you do not allow unauthorized access to anything. Coming next, so we have seen that why do we need cybersecurity? What is cybersecurity and what is not? And we have seen how does it influence others' lives. Now, there are few applications of cybersecurity in the real world. There is hacking, there's ethical hacking, and there are different kinds of attacks. Today, we'll be looking at a few web application attacks. First up, we have DOS and DDoS. So, what is the primary difference between those? So, DOS stands for denial of service. It is basically when a computer or a device tries to exhaust all the resources of the server or the network with traffic to exhaust its bandwidth. So, suppose I take my laptop and there's a server somewhere. So, I try all my might so that the server crashes, and as a result the system is not able to fulfill other requests. Like, so there's my friend who wants to access the same website. He or she won't be able to access it, right? Now, coming to DDoS. DDoS stands for distributed denial of service, and the name over here, as it suggests, over here we do not just have one desktop or laptop doing this. We have multiple laptops making sure that the denial of service takes place. You can look at this simple GIF that shows the difference between both of them. It shows that DDoS tries for multiple laptops, and DOS, it is just a single desktop. Next up, we have phishing attack. So you might have seen this as a child, or you might have seen the people around you doing this to kids around you. So they try and give something fancy to it, and then they give something the kid might not really want to eat in the first go. So this is kind of a fishing. They're trying to fish the child into eating something that they don't really want to eat after out of their own interest. They're disinterested towards it. Now let's see what is it related to in cybersecurity. So phishing is the practice of sending fraudulent communications that appear to come from a reputable source. So over here we can see that this screen has been very visible to many of you nowadays. Many people are getting fished on Discord. So this link appears to come from Discord, saying that they have gifted you a free Naito subscription for 1 month. Now, if you observe the link properly, it shows that it's discords.gift, and it's not discord.com or discord.gg that the Discord usually uses. So it appears very similar to what Discord's domain is, but is not the same domain as Discord. So when someone clicks on this link, they get fished. with their with whatever servers they are part of. They spam, this message gets spammed, and there are various other malicious actions that take place that shouldn't have taken place in the first case entirely. So in cybersecurity, like people also try and steal sensitive data like their credit card information or login information, or even try to install malware at times in a victim's machine. Next up, we have man in the middle attack. So over here, we can see two people communicating, and a third person is trying to intercept the conversation between both of them. Similar to that, what man in the middle attack is actually, or also known as eavesdropping attack, they occur when attackers insert themselves into a two-party transaction. So you can see that both the people on call are two different parties, and the attacker is inserting himself into the transaction taking place over here. Right now, they're on a simple call, but imagine this case while they are on a business call, or suppose a company is in contact with his bank relationship manager, and details about bank account transactions are taking place. Then what? The third part, the third person, the man in the middle, gets hold of information he's not supposed to have in the first place. So what does that make? That basically compromises data, right? And which is a very risky situation. I hope you guys have understood whatever I've said on how what we have seen over here. I see that the chat box is really active with the comments saying that they have faced phishing on Discord and they have seen people. I mean, that has been taking place regularly nowadays. And we need to make sure that we do not click on malicious links and we do not click on stuff that are not supposed to be clicked, right? Um, Next up, we will be looking at different tools and technologies used for different purposes. Kali Linux is a Linux distribution that has tons of tools that can be used for the purposes of cybersecurity. And it comes pre-installed with all of these tools. So you do not need to do the grunt work of installing each one of them manually. Next up, there is Burp Suit. It is an application that is used for parameter tampering. So basically, you can tamper with parameters and by using Burp Suit. Metasploit is used to exploit different stuff that take place. Beef, also known as browser exploitation framework, is used to exploit browsers. SE Toolkit is used to socially engineer people into stuff like phishing, send in malicious content, and send in other stuff to them. And finally, let's know a little about skills and certifications. So there are different types of skills and certifications, including certified ethical hacker. These help you basically what these courses or skills certification do. They help you get a validation, and they also show it to you. Like it also allows a potential employer to judge you or to validate, like to know that this person has learned something and he has the knowledge to do that, right? Coming up next, what do we do in IEEE with respect to cybersecurity? We have hosted a CTF in past, and we go to many common CTFs. We go to CTFs as a team, participate, learn, and explore different CTFs. Apart from that, we have had seniors who are certified ethical hackers and have done GSOC under OASP program. Basically, OASP is an organization that is linked to cybersecurity, and we have had internal sessions with employees from organizations like Twilio. Here we can see Mr. Yashveer, who is the director of product information security information over there at Twilio, and he had a session with us. I guess no one has any doubts. If you have, then please put it up in the chat box. I'll be ready to help and answer them. And not to forget, we have a curated list of resources that for the which we'll be sharing our link on the chat box. Please look into them. They are an excellent way of getting started with different domains with respect to cybersecurity and your pathway to grow as a as an individual who wants to learn cybersec. Do we have any doubts? Oops, no doubts. Fine then. Next up, we have Vibhuti, who would be taking up UI UX. Um, Hi, Vibhuti.
Hello, Anish. Just a mic check if I'm audible and my screen's visible.
I'm adding your screen. Yeah, your screen is visible and your audio is also audible. Over
Alright.
to you. Have fun.
Yeah. Thank you. Good evening, one and all. I am Vibhuti Arora, and the topic we have in the house today is UI UX. That's okay. You don't have to get so intimidated listening to the topic. I know it gets a little confusing, but we'll go on it slow. So, I want to start with the quote that Steve Jobs stated that design is not just what it looks like and feels like, design is also how it works. So, here you see a very pretty red, glossy teapot, but would you actually want to use it? I mean, I see no use case of this by the alignment of the handle. Now, if you see the picture right next to it, it's a gardening can, but I wonder who would use it. I agree, it's a very pretty blue one, but it actually again has no use case. What's the point of putting water back into the can than the plants? So, I'll be stating something which I've come across a lot number of times. So people have this misconception the UI UX is the same thing. I'm sorry, but you're sadly mistaken. So let's handle them alongside. UI. The UI in UI design stands for user interface. So the user interface is the graphical layout of an application. So UI has to do anything and everything with the typography, the color palettes, the scroll bars, the boxes. So everything you're seeing on the screen right now, all the visuals, everything all in all comes under UI. Moving to the next thing, UX. UX stands for user experience. A user's experience of the app is determined by how they interact with it. A good user experience would be if a user is hanging on to your app for very long, is coming back again and again, is using your app very frequently. Well, a bad UX would be if the user has limited interaction, doesn't come back more often, and just uses it once or a couple of times. So you realize having a good UX is very important because that helps hook the users on to your product, your app, your website, everything. Well, now that we've seen them separately, let's see them alongside. The difference between UI and UX. UI has to do everything with look, feel, responsiveness, how you interact, how the product interacts with the user. So till the product doesn't interact with the user, I know might sound funny, but if you don't see the app, the product fulfilling what you're expecting, then actually it's a bad UI. Whereas UX is something completely different. UX involves strategy, content. So it has more of psychological thinking. It's not clearly just the visual things. It's clearly what is where and why is it. So it's basically seeing that am I catering to the needs of the user? Am I developing a good UX? Am I having enough interaction with the user as they are expecting? So I feel like the next topic we have here is UI UX trends. So I feel like these trends are very important because it's very important to stay updated. The first one we have here is animated illustrations. I know it sounds a little confusing, so I'll break the words for you. Animation is actually the easiest and the catchiest word to tell a story. Yeah, you heard it right, story. I feel like every design is not just a mere picture drawn there, not mere just sketches. Every design, every color has a story. They have to depict the story. So illustrations is anything you're seeing visually, like the bag of vegetables, omelette, and everything there. That comes under illustrations. And illustrations add, I feel they add a very human and a personal touch. You feel like that is something going on there. But if you see, imagine illustrations seeking attention, and then imagine having the illustrations in an animated form. I mean, I cannot even explain it to you how much interaction they would gain, because I'm sure while I was speaking you were busy seeing both of these animated illustrations. Moving on to the next one, micro interactions. Micro interactions is everywhere on all apps, on websites. Well, you don't trust me, I'll tell you what. You were seeing me through the YouTube window where you see IEEE-VIT Velour. And you also see a subscribe button there. Please click on it. I'll wait for you to click on it. So, in case you clicked on it, you saw the subscribe button changes to subscribed. That's something called micro interactions. See, I told you it's there, but you don't realize it. So, I believe that micro interactions is everywhere around you, all products, all websites, all apps, but you don't really see it. But when you remove it, then it feels like life seems a little incomplete. So, micro interactions is actually good UX. When you see that the app is interacting with the user would also want to interact with the app. It's a two-way lane. The next one we have here is advanced cursor interactions. I don't think I need to explain anybody what a cursor is. It's pretty much clear that's an integral part of a website. And I feel like a cursor is the most important part where the visitor, the user will always have attention because that is what gets you to navigate all through. So cursor is actually the most important. So we've seen, cursors develop over a time. It's not just mere this arrow. Some people make it hands. It's colorful. It's good UI. Now, can you imagine having a little animation there? Like, well, the cursor's moving somewhere, you'd see the colors change, the typography change. I mean, I would just be so miraculous, and the user would be really concerned on where the cursor's going and would just keep their attention there. That's all about the UI UX trends. Well, I'm sure you guys love the UI UX trends. Now, something must be coming to your mind like, that's good, but what do I do now? I mean, how do I get started? So here's a list of number of tools you can get started with. Don't get so overwhelmed. You can just pick up one or two at a time. Sketch for, say, wireframing, Figma for UI and UX both, Adobe XD. I think at least 2 or 3 of them names are very common to you guys. You would have heard it. So I suggest take one at a time. Even if you can't do heavy drawing, that's not an issue. Just take the pen tool, take the pencil. Just act like MS Paint. Like just let's just live our childhood days again. Just feel the design. There's no compulsion on everything has to be gone in symmetric way. You learn your way through it. So as a designer, I feel it's very important to have some inspiration. You look up to designs, you feel like, oh my god, that's a good color palette. There's some design feel, like the way you scroll through Instagram the whole day. As a designer, I scroll through Dribble, Behance, all these the whole day because they actually add a more sense of design to me. So while we go next, I want to give you a sneak peek to the IEEE's projects we've been working on, the entire IEEE design team. I'm sure you'll love them. The first one we have here is Links Tier. So this is a very own curated link tree page, personalized and customized by the IEEE team, designed completely by us. You can see that's the desktop view, that is the phone view, and that's the admin panel. The next project is the IEEE website. Oops, I was not supposed to reveal it, but I showed it to you guys because you guys are here for this session. This is actually coming up very soon, and you see some very pretty neomorphism. It looks like gorgeous 3D shapes. Yes, and they look even more pretty on the website. So the website will be up soon. Please take a look. I'm sure most of you here know what Enigma is. It was our online cryptic hunt last year, and it was right on the charts all over. In case you didn't know that, please, whenever you get time, go through our social media handles, Instagram, check out posts, leave comments. We'll be very happy to see those. Well, most people talk about taking tech as a career. I don't think enough people talk about taking design as a career. Well, people laugh at the thought of, oh, well, do designers get paid? Well, I'm sorry, designers do. Design is one, UI UX designer is actually one of the most paid jobs in the tech industry at the moment. I'll tell you why. As we are progressing, everything is coming to a revolution. Do you realize a piece of code can actually be replaced by a library? Everything can be replaced very quickly. You get machines to replace humans, but you know what cannot be replaced? Yeah, that's creativity. And I feel like as a UI UX designer, your foundation stone is your creativity. So you know what? If you take it up as a career, you trust me, your career is not dying anytime soon because creativity can never be replaced. Last but not the least, every great design begins with an even better story. Yes, you heard it right. A story. As I spoke about it, design just not merely have to be very dead figures there and there. Make sure your designs convey a story because till the time they don't, the user there will not be interested in your design. So, for the last thing that I have to say, my presentation ends here, but your story begins now. All the best and thank you. Over to you, Anish.
Thank you, Vibhuti. It was an amazing session about UI UX. I'm a designer myself, and I very well loved listening to it all over again. It was very interesting. Next up, we have Shubhangi, who would be taking up graphic design. Hi, Shubhangi.
Hi.
Yep, I'll be adding your screen. Hope your screen is visible to everyone. Now, stage is all yours now.
Amazing. Okay. So, hello everyone. My name is Shubhangi Tiwari. I am a designer at IEEE-VIT, and today I'm going to be talking to you guys about graphic design. So, when you hear the word graphic design, I just want to know what comes into your mind. If you are not thinking of something, then try to think of something. Is it some sort of image, maybe an illustration, maybe a poster, maybe a logo, something? What is it that you're thinking of? Just type in the chat box if you can. If you are thinking of something along these lines, along the lines of these images, then you already know what I'm going to talk about today. Graphic design is a very creative and very exciting field. But let's try to understand what it is first. When we break down the word graphic design, we get graphic and design. Graphic is anything that is visual, anything that you see, whether it is art or maybe painting, maybe a digital art, anything that is visual is graphic. And design is basically the process of planning how something would look before it is actually even made. Put them together and you get graphic design, which is the art and practice of planning and projecting ideas and experiences with visual and textual content. If this definition went over your head, don't worry about it. Graphic design is basically visual communication. Let's try to understand what visual communication really is. What you see here is a beautiful piece of graphic design made here at IEEE-VIT by one of our most exceptional designers. Now, really look at this image. What is it that you see? At first, you probably saw this guy who's like looking out of a window, right? He's like looking at this building, and this building has a lot of words written on it, and there's some sort of logos, there's a lot of blue color in it, something's happening. But if you really look at this image, you see domain names, you see the IEEE logo. What we're trying to tell you here are all the different domains that IEEE-VIT covers. Now, this information was communicated to you visually without us explicitly, actually, literally saying something to you. That is what is graphic design. You looked at something that was visually appealing, you were attracted to it, and you got the message we were trying to tell you. This is therefore an excellent example of what graphic design is. It is also currently our GitHub banner, so do check it out if possible. Also, a very cool fact, when we tweeted this design, Figma liked it. Now let's try to see what graphic design is made up of. There are 7 building blocks or 7 elements of graphic design: shape, color, space, form, line, value, and texture. Any design that you see is basically a combination of these 7 elements. But these 7 elements can have infinite combinations, right? You can make so many different combinations with these elements. That is the reason why there are endless possibilities to how a design can end. Let me pivot to a personal experience here. When I came to IEEE-VIT, my very first design project was to make an Instagram poster for a Discord bot called Heimdall. So what you see at the bottom is the final posters that went up on an Instagram page. And what you see on top is the very first design or the first iteration of this poster. Now that you look at it, they look polar opposites. The color scheme is different. The style is different. They look completely different from each other, but they were meant for the same purpose. The reason they look different is because the combination of elements here is different. That is how much it matters. But I guess that's what creativity is, right? Just trying out different things and seeing what vibes with you. Another fun fact, or maybe not so fun fact, the very first iteration is this one. And the final iteration that you see at the bottom was the 8th draft or the 8th design for this poster. So I had to make 8 different iterations to get it approved. As a designer, this is a very, very real struggle. If you're working on a project, get ready to make many different drafts of it, because whether it is your paranoid designer brain or your paranoid client, you're going to be making many more iterations till you get the final one. But you know what? Let's just look at the bright side of things. There are many different things that you can do in graphic design. Personally, I feel that graphic design is everywhere in today's world. I mean, just think about it, okay? A company or an organization or even a shop, they all need a poster, they need a logo, they need something that involves graphic design. You see it everywhere. Just think about it. This presentation, this PPT is graphic design. The logo of Techloop is graphic design, right? But to make it very simple for you, I have condensed them into 6 different fields. So there's logo and branding, which is very popular. There's packaging, which basically involves item packaging. There's obviously graphic illustrations. Then there's print and publication, which is your magazines, your book covers. Then there's UI UX, which is user interface. All the websites that you see, all the beautiful illustrations that you see on app, that is also graphic design. And then there's lettering. Where is it that you can do graphic design? I'm pretty sure that all of us got connected with our creative side in the OG MS Paint, but there's a lot more sophisticated and specialized applications out there where you can try out graphic designing today. The very first row that you see is all Adobe applications. There's Illustrator, Photoshop, InDesign, and XD. Then there's Figma, Sketch, Affinity Designer, and Canva. If you are trying to start with graphic designing and not sure which software to download, I would just say that any of these 8 would be a good to go option for you. Because it really depends on the designer which software they prefer the most. Everybody has a personal, relevance to the fact of the way they're designing. They have a different choice. They like different kinds of things. So you can just choose what kind of software suits you best. Personally, I prefer Figma for any kind of designing. And when I have to do vector-based illustrations, that's when I use the Illustrator. Let's talk about work. If you're planning to work in this field, then you should really start working on something called the portfolio. It is the most important thing to a designer, and it is basically the combination of your best work. You can flex it to your family and friends, but more importantly, you can show it to potential employers, clients, so that you can get a job, get work, maybe try freelancing. So when you're starting to design something, you always look for inspiration. You try to find a mood board. You try to find a color palette. But sometimes inspiration just doesn't strike on its own. That's when you can use different websites. Pinterest is the best website to get inspired for designs. You can find amazing mood boards. You can find amazing designs on there and even get ideas for color schemes. There's also Dribble and Behance, which can give a lot of inspiration to you. But another added advantage to Dribble and Behance is that you get the opportunity to connect with more design communities, connect with more people who are into the same things that you are in. And therefore, just understand what is going on, keep up with the latest trends. So if you're planning to work in design, any sort of design, I would suggest that you make an account on these websites today. Now it's time for me to flex some amazing graphic illustrations we do here at IEEE-VIT. Everybody has talked about Enigma so far. Enigma was a cryptic hunt that we conducted last year. And these are the 4 best graphic illustrations that we had. There were many, but these are the 4 best ones. If you want to look at some more of our posters, then just scroll down our Instagram page whenever you have time. Now, for all of you guys present here, we have an exclusive sneak peek at our upcoming Instagram rolls. It's not out yet, but you get to see it first here. And it's all about The Office. So I really hope that all of you guys who are The Office fans are really hyping it up in the chat right now. These graphic illustrations, as the previous ones, were made completely on Figma from scratch by our exceptional design team. And you can keep looking at our Instagram page to see what's coming up next for you, because it is going to be amazing. Let's talk about the demand. With everything going online today, graphic design has only increased in demand. Your classes are offline, events are offline, your office is offline. Therefore, there is an increased need for more visually pleasing content. That's where graphic design comes in. Logo and branding are the topmost graphic design requirements today. Let me tell you a very interesting fact. All of us have heard about Tropicana, right? Like, you probably have had Tropicana, the juice. If you've not had it, you must have heard about it. The redesigning of the Tropicana logo cost $35 million. That's how big logo designing is in today's world. Let's talk about what you can do in college with graphic design. Well, graphic design is extremely popular among students today for many different reasons. Some people are just into it because of a hobby, but some people are developing it as a very useful skill. If you're part of a club or a chapter, you can probably use it when you are making posters, when you're trying to make a website, when you're trying to make any sort of project that you're working on that needs design, you can use graphic design. You can also use it for freelancing opportunities, for which, remember, you will need a portfolio. Freelancing in design is extremely big right now. Companies will pay you so much for freelancing graphic design for them. So, you know what? Just try it out because there are many opportunities in this area. To wrap up, I just want to say graphic design is something that does not even require any prior knowledge. You don't need to know anything before you start this domain or any design domain for that matter. So you can try it out. All of us have scribbled onto MS Paint. So just download one of those softwares, scribble it out. Maybe you'll end up liking it. Personally, myself, I never thought that I would end up doing graphic design or any kind of design at this moment. I didn't have any kind of plan when I came to college. The reason I'm in design today is because of IEEE-VIT. In my round one interview during recruitments, I was asked what it is that I would like to explore as a domain. And I just very nervously blurted out design because I used to draw and sketch and paint. And the next thing I know, I'm sitting in that interview, flipping through my sketchbooks, showing my designs. Cut to today, I have taken part in so many designing projects, helped in Enigma and the website, the IEEE website, and all of it has been a great experience. And I'm absolutely in love with this field and just want to explore it more. So I would urge all of you all to start your design journey today. Thank you.
For that amazing session, Shivangi. I mean, it was amazing with the fact that how you did different domains. Next up, we have Anshul who would be speaking about blockchain. Hi, Anshul.
Hi Anish. Hey
Um,
guys.
yep,
So
you're audible. You can go ahead, Anshul. The stage is yours.
yeah. So Shubhangi did a really good work of selling you guys on design, right? But I'm here to make a proposition that blockchain is the hottest thing in tech right now. Let us see how. Okay, to start with, let me be very honest. When I first joined IEEE, this is what came to my mind when I heard of the word blockchain. A block chained together. But that's not it, right? Like obviously it has to be more than this. But you would be surprised to know the similarities. A blockchain is really a chain of blocks, just that those blocks are digital. Let's go to the technical definition. A blockchain is a decentralized distributed immutable ledger. Whoa, that is a lot of jargon. Don't worry, we will break it down and understand one by one. Let's start from the reverse order. Let's take the word ledger. What is a ledger? It is a book. Think of it as a logbook, a collection, a table where you can record data of transactions. Those transactions could be anything. Maybe I can pay you some money. So, like, I pay you rupees 500. That counts as a transaction. You attending this event, this Techloop Alpha, is also a transaction. The teacher taking attendance in your classroom, that's another transaction. So a ledger is nothing but a record book which records the transaction. But what's so special about it? The speciality of this ledger comes from its immutable property. What is immutable? Something that cannot be mutated or changed. So what does this mean? So when you write something in this ledger called blockchain, it's carved in stones. Once it's written, it can't be changed. So that's what immutable means. What is distributed? So the same copy of the ledger is copied digitally and distributed among all the users of the blockchain network. Right. And this gives it the property of decentralization. That is, no central body is an authority of the network or the chain. So, like, there is no owner. Every user of the network is the owner. So, let me repeat this. Blockchain is a decentralized, distributed, immutable ledger. That is a record book where you can record transactions, and once written, that can't be changed. And that there is no single owner of this record book, and it's distributed among all the users. Uh, okay, that's still complicated. Let's see some visualizations. So this box encapsulates a transaction. So there are two people inside. They commit some transaction. So let's think of that as a record, a single record. And this record forms the part of a larger block, the ledger, which we just discussed. So a transaction is a record, and a transaction form part of a greater block, which is the ledger. And multiple such blocks are chained together using something called a hash, and that leads to the formation of a blockchain. Right. So this is a beautiful visualization. I want you to look at it again. Okay. So decentralized, immutable, distributed, ledger, those are lots of heavy words, right? And yeah, but why should you care? You should care because of the applications. To begin with, cryptocurrency. All of us are quite familiar with this now. So blockchain is the basis of cryptocurrencies. And cryptocurrencies like Ethereum, Bitcoin, Dogecoin. So why use cryptocurrencies in the first place? So when you make a transaction using cryptocurrency, first of all, no one can track you or trace your transaction. So it can't be taxed by the government, and you can make international transactions without the charges that the international financial institution levy on you. So that's why cryptocurrency. But you would be surprised to know cryptocurrency is not the only application of blockchain, but an isolated one. So another one is medical records. You could store your medical records. So medical records by its nature is very sensitive information. You don't want it to be altered or tampered with. So like if you have a disease and it's stored digitally in some database and someone changes it, so you would be in trouble, right? So medical records could be stored in blockchain networks, and that way it's legit. Then there is the concept of blockchain based voting. National and state election could be moved on chain. This will lead to transparency and tamper proof elections. And the next thing is banking and finance. So the financial institutions have been heavily investing on blockchain. They do this majorly to simplify their record keeping and payments. And there are whole domains like DeFi or digital finance, insurance, papers, all of them are moved to blockchain. And even some startups are working like to sanction loans using blockchain. So yeah, this is a blooming field. Okay. So you saw all these applications, right? Now, all these technologies, be it cryptocurrencies, NFT, DeFi, DApps, all these are leading to creation of a whole new internet. This internet is called Web3. For reference, the current internet, which we all know of, that's Web2. So Web3 basically refers to the decentralized online ecosystem based on blockchain platform. So platforms that are built on Web3 will obviously, there will be no central gatekeepers like we have big tech companies today to like keep make their own rules. So let's understand this better by comparing it with the current web, which is Web2. So currently this is how it works. The economic incentives are aligned in a way that a company either charges you money to use their service and put their service behind a paywall, let that be Amazon Prime or Netflix, or there are another variants of companies like YouTube or Facebook, which sells your data to advertisers, and that's how they monetize you basically. But we can do better, and that's what Web3 does. In a Web3 world, you are in charge of your data, and no one can sell it or even like read it without your permission. Another interesting topic revolving around blockchain is the concept of smart contracts. Smart contracts, put simply, is the program that are built on top of a blockchain. And so it's basically a programming function, and it gets executed when a condition is met. So think of it as a real world contract that two person or companies make in between them. But when you do it via smart contract, there are no gatekeepers, there are no executors, so it will be executed. Like no one can change this once a contract has been signed. Using the concept of smart contracts, there is an interesting field of apps that you can make. It's called DApps or decentralized apps. They operate autonomously through the use of smart contracts. And yeah, so you could go to various hackathons and even build your own Web3 app or DApp. But how? So these are the basic things. The language that you use is Solidity, and so if you want to make a front end for your language, you can do that in React or any other framework. If you use React, then there is a package called Web3.js, which you can use. For authentication, you use a wallet in the Web3 world, and MetaMask is the most popular wallet. And similarly, the network infrastructure, that's Ethereum, that's most developer friendly. And yeah, so all these are intimidating, I understand, but to take a deeper dive, all these resources are available in our IEEE repo, and we will share that by the end of the session, so you can take a better look at it. And so that's how easy blockchain is, really. So yeah, I will summarize this. Blockchain is a decentralized, distributed, immutable ledger. The media has only focused on the cryptocurrency aspect, but this tech is fueling a whole new internet paradigm called Web3, and there has been explosion of opportunities in this space. Recently, blockchain devs have been started to get handsome payments from both MNCs and startups. Even the central government introduced a scheme to introduce their own digital currency. So even we have government jobs in cryptocurrencies now, and yeah, this is a very new domain. So a new learner is as good as an industry expert. So that's another advantage of taking up this domain. And what do we at IEEE do with blockchain? So there is an ongoing project where we are building our own blockchain network. Really, like we have Bitcoin and we have Ethereum network. So we are building our own network. And also we conducted a recent hackathon, and the winner got a prize of an NFT, which is really cool if you ask me. So if you want to be part of all this cool initiative, you know what to do. So yeah, that was blockchain. Over to you, Anish.
Thank you, Anshul. I mean, it was a very apt explanation of blockchain in this short span of time. And blockchain is very, very fascinating, very cool for what it does in today's world. It's the buzzword, and NFTs have been in the demand, in the trend. So you've covered
Absolutely.
it all, and I understood everything, and I hope others who as well understood. For those of you who have any doubts, please join us in our Techloop community server. We are always there to help you out, or else please do put it up on the chat box. We are there to solve them as well. Next up, we have Anshita, who would be taking the session. Hi, Anshita.
Hi Anish, mic and screen check. Is it visible
Yup, you
properly?
are visible and audible, loud and clear. Stage is all yours now. Thank you.
Thank you. So, good evening everyone. I am Anshita and I'll be taking your Tech Loop session today on game development and AR. So, I'm sure there are a lot of gamers in our audience, right? So, what all games have you people played? I'm sure there must be a lot of gamers who have played PUBG and Valorant, right? You can put it up in the chat box. Okay. So, what if I say that you can make those games? Like, isn't it kind of cool? Like, how amazing it is to have your own version of Minecraft, right? Have your own version of Valorant. So, I will take you. I will let's dive into how to start your game dev journey. So, what exactly is game dev? I mean, everyone here knows what game development is, what game is, but what exactly does it mean? So, imagine that you have your own assets, you write scripts on different levels. The entire game is yours. You have your own personalized game, which you make for others. That is exactly what game development is. So to exactly quote it, it's coding your own creativity. Now, let's talk about how big the game dev industry is. So, Endgame, one of the biggest hits, generated a revenue of 2.7 billion. But PUBG, on the other hand, as you can see from the slide, generated a 2.8 billion revenue last year. And guess what? It won't stop. It will keep on increasing because PUBG will keep on will keep on pushing the updates, right? So, I mean, you guys can figure out how big the industry is. I mean, there is a myth that only a certain group of people play games, so it might not generate a lot of revenue. But trust me, it's a very big event, very big industry. It has a lot of opportunities, and I'll show you throughout the session. So now let's start with the basic game dev industry. So you divide your games into two major aspects. One is 2D and another is 3D. I personally love 3D as I can develop assets and I can use it to make games more personalized. Like, who does not like a personalized game, right? Now, let's understand the most important aspect of the game dev. So, here are the three major aspects: scripting, 3D modeling, and designing. So, let me explain this more clearly with the help of an example. So, let's take an example of racing car game. So, in the scripting part, we write the code basically. So, how the car will move forward, how the car will move backward, or how will it turn around, how will it go over a speed breaker. All of this comes into scripting. Now, going on to the 3D modeling aspect, so all the visual things that you see in a game, right? Whatever you see on the screen, the car games, the tracks, the trees, the flag, all whatever you see in a car racing games, all those are 3D models, and those are what made in the 3D modeling, right? And the designing aspect, it's like the one of the most important aspect of the game development. So in that we basically combine both the scripting and the 3D modeling aspect of the game. In that we basically attach the scripts to the game objects, to the 3D models that we have developed, and it basically gives us the end product of our game, of the game. So now we have talked about what games, 2D, 3D, what exactly we have to do to make a game. So now let's talk about how do I make a game. So here are game engines. So here is a list of game engines which are very famous on which you can make games. So earlier it was very hard to make games, but with the help of game engines, it has become a lot easier. It's as easy as dragging and dropping your assets from your files to your scene folder, right? Even a beginner who has just started game development, the person can just develop a game within 2 to 3 hours with just dragging and dropping and changing some of the settings, right? So that's how easy game engine has made our life for making games. So I think you can see some of the major game engines, right? Have anyone of you heard about these? I'm sure some of you must have heard about this, right? Either Unity or Unreal. Yeah, I see someone has written Unity in the chat box. So now let's come on to one of the most famous game engines that are currently used, Unity and Unreal. So it's always a debate discussion, like which one software should a beginner go for, like which one should I use, like if I do this, if I do that, which one suits me more. So I would say both of these engines have their pros and cons. I, as a Unity developer, I am a Unity developer and I've also worked on Unreal, and I've liked the blueprints that they have provided. So it's up to you which one you wish to go for. So let me break it down to you a little bit on which game engines provides what. So Unity, it's a beginner friendly software. It has a huge community support. So if you are a beginner and you have any doubts, you can easily go onto the internet and write whatever you doubt you have, and you'll probably get an answer to that, right? So it's very user friendly, very beginner friendly. Now coming on to Unreal, as you can see from the example only, it provides high class graphics. Like if you have to make proper games like with high quality graphics, Unreal is the one for you. Now, if you are not a person who wants to go into coding, or if you're a person who doesn't like the designing aspect of the game development, you can venture into the 3D modeling aspect. So, here are the two softwares on which you can do 3D modeling, one being Blender and another being Maya. So, Blender is a free open source software and it has a huge community. So, just like Unity's community support, even if you type a doubt whatever you have faced in Blender, you will most probably get an answer to that. And Maya is used in the film industry for animation. So I guess you can figure out which one you might want to go for whatever type of project you're going for. So to basically summarize what game development is, so that was the basic overview of the game dev. If you guys have any doubts, let us know in the chat box. We will be sharing a resources library specially created for beginners by IEEE-VIT. Hope it helps you. Now let's come. Now coming on to augmented reality. Okay, now it's a fun and a cool part of the presentation. Have anyone of you heard about augmented reality, made something in this domain, played something? I'm sure everyone must have played a thing about this domain, right? So I think the example says it all, right? So our good old Pokemon Go, that was one of the most famous AR apps that are out there. They are still out there. So, what is augmented reality? So, if you guys want the bookish definition, I have provided you that. But if I had to explain it clearly in basic layman words, so let's break down the word augmented reality. So, augment means adding objects, and reality means real world. So, if we combine these two together, it becomes basically adding objects to the reality. It's as simple as it can get, right? I mean, in Pokemon Go, your Pokemons were there in your reality. Like those were virtual objects, but those were in your reality only. Now, coming on to AR and VR, I think some of you who have heard about augmented reality and virtual reality might get confused between what is what, because I was confused 2.5 2 years ago when I started this domain. So let me clear it out a bit. So as I had explained earlier, AR, it's basically adding virtual objects into real world. But virtual reality, it's completely virtual. You interact virtually. You have a fully immersive virtual environment, right? You are totally isolated from your real world. You cannot hear your mother calling you at the back like, please go and study. Okay, so you're totally isolated from the real world. And in augmented reality, you still have contact with the real world, but again with the hint of virtual objects here and there. So this is one of the basic difference between AR and VR. So now let's talk about something interesting. So we at IEEE have started incorporating a lot of AR culture into our chapter. So this is one of the few examples that we have started. So the photo on my left is the filter that we made for Enigma 8.0. If you guys go to our Instagram handle, you can check it out. It's there. So it's a face detection filter. So basically, it detects your face, and on my right is another filter from Enigma 7, which basically detects the plane and places your object there. So in Instagram, most of the filters are face detection based. Right, I'm sure everyone must have played around with Instagram filters, right? So everything depends on if it detects your face or not, right? So we talked about, you saw a lot of AR, what AR, Pokemon Go, and everything. Now, how to actually make AR apps? So, to be honest, AR is basically game, but instead of a screen, it's just a camera, right? So, I mean, you can always change the view, right? So it's the only difference between AR and game is a screen and a camera. So as in game dev we use Unity, even in AR you can use Unity to build apps, right? So in Unity there are a few SDKs that are used to make AR apps. I have shown it in the slides. ARKit is used for iOS, AR Core is used for Android, and Vuforia is used for both iOS and Android. There is another SDK called AR Foundation. It's also one of the most frequently used SDK used to develop AR apps. Now let's come on to the most famous and the most frequently used part of the AR industry, right? Filters. Again, we have two examples of what we at IEEE do, how we incorporate AR. So again, we have these two filters from Enigma 8.0 and Enigma 7. So the two softwares that you can use to make filters, one being Spark AR. So it's basically developed for Instagram and Facebook. So when you make a filter on Spark AR, you can basically publish it on Facebook and Instagram. And on another software is Lens Studio. It's basically for Snapchat. Nothing too fancy. These are the one of the two most frequently used softwares to make filters. Right. Now, coming on to the applications, I'm sure some of you must have tried some way or the other, must have seen these applications somewhere, right? So, AR has several applications. From the fashion industry to the game AR industry, AR is like everywhere. It's still a little bit it's not exactly popular, but with time, I think you can see how AR is growing. So I don't know if you guys have seen or not. So Lenskart has a feature which shows how glasses look on you. So if you select a particular glass, they have an option on with the help of which you can see how the glass looks on you. So that's one of the applications of AR, and it's been out since 2 to 3 years, if I'm not wrong. Right. So AR is also used in the medical industry. So as shown in the example, look how easy do you think it will be if you can access a patient's history with just one swipe. All the history, all the medicines, a doctor can just view it in one swipe. I mean, if you guys have you guys seen series called Good Doctor on Netflix? I mean, if you guys have, then you guys exactly know what I'm talking about. That basically explains how VR and AR can play a very important role in the medical industry. Now, coming on to the education industry, um, okay, how easy would it be to understand inorganic chemistry with the help of AR? I mean, at that point, yeah, inorganic chemistry would just go over my head. Yeah, I had no hopes from that, right? So like, but think about it, how easy it would have been if AR was there, right, to help you understand inorganic chemistry. And also, if you notice in the Akash Byju's app ad, there is AR present. I mean, if you guys still haven't noticed, um, I'll tell you, like, just whenever the ad comes, just like focus on little bit, like you might notice that AR is present there. So that's all from game dev and AR. I hope I got you a little bit interested into AR and you might wish to pursue that or maybe even play around with filters. I mean, filters is one of the cool things that, and it's not quite difficult to make actually. So I wish you best of luck on your tech journey. Thank you. Over to you, Anish.
Thank you, Anshita. It was an amazing presentation about game dev and AR VR. I mean, I really loved it. These are some really cool stuff that you can play around with, especially the Enigma filters. They were really amazing.
I mean,
I
you can
mean,
go check it out on an Instagram handles.
so next up we have Alok, who will be taking up CC. Hi, Alok.
Hi Anish, can you hear me?
Yes, Alok. Stage is all yours now.
Okay, hello everyone. This is the last session. Hope you're not tired after a lot of like 10 domains. So, we've got a really interesting domain coming up. It's competitive coding. So, let's get started. What is competitive coding? It's you can call it a game, you can call it a contest, or you can even call it a sport. Okay, you code in a competitive environment to solve some well-defined problems. That could be related to algorithms, data structures, and basically just logic. Okay. So for freshers of VIT, you might be familiar with the problem of the day that you have to solve within a couple of hours. It gets released around 8:30 every day, I guess. It was a really thing when we started in CP. like when we were freshers. Okay, so now that is CP, or competitive programming. You see the problem, you see some test cases, which we'll come into soon, and you kind of try to build up a solution to get a proper output out of that, to solve that problem, right? So you work out a solution. So now let's break up a few terms that you guys might have heard. So basically, we're talking about programming, right? So what does a computer program do? Basically, it takes some input from the user, it processes it, and while it's getting processed, there is some storage happening, like there is some IO between the storage happening, there is some putting in the storage and getting out of the storage also, and then after the processing, you get an output. That's what does a computer program do, or a computer does. So when you see it this way, any program that does the job works as a computer program. But as a responsible programmer, you should make sure that your code is efficient so that it runs the same both on a low end PC as well as a high end PC on any machine. And for that, two things. You have to take care of two things. One is time, and two is space. Oh, no, no, not that space, that space. So, yeah, not the interstellar space. I meant the memory of your computer. By time, I don't mean how much time does your program takes to execute in seconds or something, because that might change for different inputs, right? So, and for space, I don't mean how much memory in like bytes or megabytes or kilobytes. I mean the exactly how much it'll take for every program. So there exists a generalized notation which will let you say your time complexity and space complexity of your code. Now, what is this time complexity and space complexity? Let's check it out. So, time complexity. Taking a simple example, okay. So basically, it is what you said. I mean, it is what I said. It is the amount of time taken to run the program. Yes, but it is a function. Okay, it is deployed. I mean, it is said as a function. Okay, so taking a simple example, this for loop that you can see here, it has a time complexity of O of n. I'll let you know why. Okay, so this for loop that you see here has, as you can see, it's an int I is equal to 0, I less than n, and I plus plus, and it just prints something. So this for loop will run for how many times? N times, right? So that is why there is an I less than n. Okay, so this, when it runs for n times, we can say that it has a complexity of O of n. I'm just giving a simple example here, and I'm considering that this is the only loop in your program, or only kind of loop in your code currently. Let's get it a little bit deep. So what if there is a nested loop? So basically what a nested loop is, you can see there is an I is equal to 0, I less than n, and inside that loop there is another loop. So in the first iteration, say I is equal to 0, j will become 0 to n. So j will run n times, and then for I is equal to 1, j will run n times, and for the first for loop will run n times. So how many will it be? It'll be n square. So for the first I, it'll be n, and for the second j, it'll be n. So it'll be n square. So what do you get? The time complexity will be O of n square. So this is just basic stuff. It gets a lot complicated when it comes to recursion and a lot more stuff. So you will learn this in your courses like DSA, DAA, but I'm just giving you a simple intro of what time complexity is. It's a generalized notation to take care of your, to say how much time your code will take to run. Okay, now there is something called a space complexity. Okay, so it is the amount of space taken to run the code, but again, as a function. Okay, so here, as you can see here in this piece of code, there is a simple int n is equal to 10 and int a of n. Okay, I'm declaring an array of size n. So that means it'll take 10 memory spaces. Okay, not we aren't saying how much, but it'll take n memory spaces. Okay, so we can denote it as O of n, again space complexity. Now, what if we have a 2D array? What is a 2D array? Simply, you can get it as a matrix. It's just as a matrix where you can have, in this example, we have n is equal to 10. So it'll be 10 by 10. Okay. So that is what is here I'm declaring int a of n. So what will happen? So each row will take n memory spaces. So n rows are there. That'll be O of n square. So this, I just give you a simple intro, and big O notation is what we call it. And big O notation isn't the only notation out there. There is a big theta notation. There is a big omega notation, which keeps it is much more complicated. So basically, I'm just giving you an outline of what time complexity and space complexity is. I hope you got it. Now let's move on to what is data structures. So let's see the program flow, or the computer program flow that we saw here earlier, right? So there is an input, process, and an output. So what do we input and what do we store while processing? So that is what is data, right? So this input is data, and we need to store this data in order to do some processing over it. And how do we store this data? That is what is done by data structures. So there are tons of data structures, and we can use these in different ways, in different languages. Anything is possible. Let me just go through some of them. So basically, again, the store part is what is more focused. Some of the data structures that I'll be focusing here is the arrays. Basically, an array. I hope you know what an array is. It'll be just basically a similar set of values stored sequentially in the memory locations. Similarly, there is something called a stack. Okay, so what is stack? This is a non-linear data structure. So stack basically does is, say you keep plates on top of each other, and you can only take the plate from the top. You can't take a plate from the middle. You can't take a plate from the bottom. You have to take a plate from the top. That means the last in, first out. The last kept plate only you can take first. So this stack is a data structure that works based on the LIFO principle, or the last in, first out principle. Then there are a lot of other data structures like linked list, queue, trees, and graphs. You can learn more about this in any platform out there, like Geeks for Geeks, Code Forces, and all these platforms might be useful to you. Now we're talking about the next part. Now we're doing some processing of the data, and how are we processing the data? And that is where algorithms come. So we take an input, we process it, and give the output. Now this processing part is taken care of the algorithms. There are millions of algorithms, but you can even write your own algorithms if you want to do a specific task. Okay, so let's see some I'm giving you an example of a searching algorithm. So we have to search from 0 to n for an array. So say we have an array, and I have to, you can see an array here, and I want to search for 47. Okay, so either I can do this, I can go through each and every element of the array, check if it is 47. That'll make me reach from the beginning to the end of the array. Okay, so that'll take that much time. You have to check each of the arrays, like each of the elements in the array, to check if the same. But if you do something like a little bit more smart, if you're sorting the array, say that means you're sorting the array in ascending order. Okay, so now I'm searching for 47. Say I'll begin at the middle of the array. Okay, so the middle of the array, you can see it is 14. So as we have sorted the array, we know that 14 is less than 47. We know what to find. That's 47, and 14 is less than 47. So we can conclude that we can leave the left part of the array. We don't need to search there, because 47 is definitely in the right part. Then we divide it again. We check the middle part of that. We keep on checking, and we can find 47 easily. So that will take lesser time than comparing each and every particle. I mean, each and every element of the array, right? So that is what is called binary search. There are a lot of searching algorithms and stuff. So basically, again, coming back to CC, how can you use this data structures and algorithms in CC? First, to solve a CC problem, read the question, see the sample test cases, check it out. How are they? What does the sample input, what is the sample output? Check it out. Then take your pen and paper and actually write it down. So write down a solution. What you picture in your brain, try to write it down. If you're a beginner, it really helps. So try to write down a solution, and then figure out the data structure. You need to figure out, you can't use always arrays. You can't always use queues. So figure out which data structure is most appropriate for you, and yeah, write down the solution in code. So choose the language you're most comfortable with, write it down. So that's all. And what do we do in IEEE would be we conduct weekly contests. I mean, weekly contests, we sit for weekly contests like in Code Chef together. We participate together. We get onto a VC and code together. It's really fun. And we have an internal leaderboard as well. It's a lot of fun that who will come up first after the contest and stuff like that. Then we have, yeah, that is what IEEE is really excited to start this new domain. I mean, CC domain. So that is it. Thank you. Bye bye, guys. So all the best. That will be all of the domains. And Anish.
Hi Alok, that was a
Yep.
lovely presentation that you had.
Thank you.
Now up next we have Arush who would be joining us, who is our tech head.
Hey Arush, what's
Hello.
up?
So I hope I'm audible.
Yep.
Yep, Arush, you're
Yep.
audible.
So thank you everyone for joining the session. It was great to have you guys here. So what you just witnessed was Techloop. So we do, as I said in the first session, we have three kinds of Techloops that we do. One is Techloop Plus, that is strictly restricted to our core of IEEE. Then we have the tech loops, what you just witnessed, the first tech loop of the year, that is Techloop Alpha. And one more thing that we have is the tech loops that we do in different colleges. So we've been for now in the last 2 years, we've been to 5 different institutes and taken sessions about these domains over there. So I hope to see you join the legacy of IEEE. Our recruitments will be live soon, and stay tuned on our socials for the URL. Thank you so much for joining the session. And I hope you all will join the Discord server that we have and see our socials. Thank you so much.